Hello and welcome to our second in a series of videos on IMS fundamentals. And in this particular video we're going to go over the IMS online architecture, sort of give you an overview of the various address spaces and the functions that they perform. So here's my agenda. We'll give you an overview of the IMS online or IMS TM architecture. We'll talk about the different address spaces. Now there are several address spaces when it comes to IMS. We have what's called the IMS Control Region, there's something called DBRC, and then the DLISAS address space. Those are the three main ones that we will be covering in this particular video. These are what I call system address spaces. They perform system work, meaning there are no application programs that execute in these address spaces. And then the application programs run in separate address spaces called dependent regions. And there are different types of dependent regions. There's MPRs, IFPs, BMPs, JMPs, JBPs. And so these we will cover in the next video called IMS Fundamentals Part 3, Dependent Regions. In addition to these address spaces, there's a whole bunch of other address spaces that an IMS customer can turn on or use. There's the IRLM address space, there are DLI batch address spaces, there's IMS Connect, there's CSL address spaces, there's repository server address spaces, and those we will cover later in other videos. In this particular video, we are simply going to concentrate on the three main system address spaces: Control Region, DBRC, DLISAS. So no matter which IMS shop you go to, they will at a minimum have the IMS Control Region, the DBRC, and the DLISAS address space. So we're going to talk about these address spaces and see what their role and function is in IMS. Now, by the way, if you're new to the mainframe world and the term address space is sort of new to you, address space is simply an area of virtual storage that's carved out for programs and data. It's kind of like the analogy that I give is it's kind of like the analogy with cubicles. You know, when you're working in your cubicle, that's your domain, that's your area, that's where your stuff is. If you wanted to access information from somebody else's cubicle, you'd have to have an understanding that you can go across into their cubicle and get that data or whatever it is you need. And so it is on mainframes. Whenever programs execute, whenever they process data, they do so within an area known as the address space, or the region, if you will. And so we're going to be looking at these three address spaces: Control Region, DBRC, and DLISAS. So here's the IMS Online Architecture overview. Any IMS customer will have some number of these address spaces started up. There's the IMS Control Region, there's DBRC and DLISAS. Once those three address spaces are started up, then the customer will probably start up some number of dependent regions. And there are various types of dependent regions. I think I mentioned this earlier: MPRs, BMPs, IFPs, JMPs, and JBPs. The dependent regions, they're called dependent regions because, number one, that's where application programs execute. And then those regions, those address spaces, they use services or they take advantage of services provided by the IMS Control Region, DBRC, and DLISAS. So that's why they're called dependent regions. To control this entire IMS environment, there is a terminal known as a master terminal. And from the master terminal, you can control the entire IMS system. You can shut it down. You can stop databases. You can start databases. So there's an operational hub, if you will, for an IMS system, and that's the master terminal. In case something goes wrong with the master terminal, the MVS console is always the backup. So you can enter commands to IMS or control IMS via commands from the MVS console. And then, of course, you've got devices or user terminals that are connected to IMS, and from these user terminals, users can enter transactions, and IMS will process those transactions and then send replies back to those end users that are sitting at user terminals. So what we're now going to do is sort of focus in on these three address spaces: the IMS Control Region, DBRC, and DLISAS, and see what it is that they do and what their role is. So let's do that. Come on over to the next page. So let's talk about the IMS Control Region. So when operations first starts up IMS, the first address space or the region that first comes up is known as the IMS Control Region. This is what I call the headquarters of IMS. This is where most of the system processing of IMS goes on. And I mentioned this before, and I'll say it again, no application programs execute in the IMS Control Region. So this is sort of the headquarters of IMS, if you will. And here are some of the things that the IMS Control Region does. Telecommunications, which is connecting to terminals. End users sitting at terminals can log on to IMS, they can connect with IMS, and then they can send in transactions to be processed. Those transactions will come in over the network. We will receive those transactions, and then we will queue them and process them, and so on and so forth. So this ability to receive transactions over the network and then send reply messages back to those end user terminals, this is done using telecommunications. And that piece of code resides within the IMS Control Region. Now, the formatting of these terminals, which are typically VTAM devices, 3270 type devices, the formatting of how you want the data displayed on these terminals, that's done by a set of modules in the IMS Control Region known as MFS, or Message Format Services. And so that's another function that IMS Control Region provides, which is the formatting of to and from messages to these user terminals, these 3270 devices, if you will. If you are from the CICS background, CICS has something that is similar to MFS. It's called BMS, Basic Mapping Service. And so in IMS, we have a different name for it. It's called MFS. We also have in IMS various pools that store various types of information, and one of the key pools is what's known as the message queue pool. Any transactions coming into IMS, when they are received, they are placed into this message queue pool in some sort of a priority order. They're queued and they wait there to be processed. So the message queue pool holds input transactions. Once those transactions are processed, then we will send a reply back to the end user. And those reply messages are also queued in the message queue pool until the program does a commit, or until the program says, yeah, I'm done, go ahead and send those reply messages out. So the message queue pool is really an area where, input transactions and outbound messages get queued, right? It's a waiting area, if you will, a queue, a set of queues. In case there's no room on the message queue pool, we have a set of DASD datasets known as the message queue datasets. So if there's a lot of transactions coming in and we have no room in the queue pool, we'll then put them out in the message queue datasets. The MFS, Message Format Services, the way they do the formatting of messages on those 3270 devices is the application programs actually build or code up what's known as MFS control blocks. And these MFS control blocks are compiled and link edited and stored in a DASD dataset called the format library. And so the format library is where MFS control blocks resides that the MFS modules use to format messages going to and coming in from end user terminals. The logging, and we'll talk about logging in a big way. IMS does extensive amount of logging. Almost anything that goes on in IMS is logged. A transaction comes in, we log it. We send a reply back out to the end user, we log it. An application program starts, we log it. An application program stops, we log it. You change a database in IMS, we log it. And we do that for one reason, which is recoverability and restart. That's sort of the key. If you watch the first video on IMS fundamentals, one of the key things that IMS provides is this data integrity and recoverability and restart capability. And we can do that because we have a log of all the things that IMS has done. So that logging is done on DASD datasets, and those set of DASD datasets are called online log datasets, or the abbreviation that everybody uses is OLS, O-L-D-S, OLS. And we'll talk about logging in a much more detail later on. So since we have the log, if IMS is terminated or if it crashes, we're able to restart it from the point where we last left off. And that restart function, those restart modules, are also within the IMS control region. I mentioned earlier that you can enter commands into IMS and control IMS via commands. So command processing modules also reside in the IMS control region. We also have something called a scheduler. So as I mentioned, transactions come in, they get queued. Well, if they get queued, what order do we process them in? Well, transactions can be assigned priorities. Certain transactions may have a higher priority. Other transactions may have a lower priority. Based upon your business, you can decide which transactions are going to have a higher priority and which ones are going to have a lower priority. The message scheduler, or the scheduler that resides in the control region, its job is to pick the next available transaction based upon priority and schedule it for processing. There's also something called dispatcher. This is a set of modules that decides what is the next piece of work that gets processed within IMS. We also have something called OTMA. OTMA stands for Open Transaction Manager Access. This is another way to send transactions coming into IMS is through OTMA. The telecommunications component that I talked about earlier dealt with VTAM devices. Well, we all know that VTAM is an IBM proprietary network protocol. Nowadays, almost everybody uses TCP/IP. So how do we get messages coming into IMS? How do we get transactions coming into IMS through TCP/IP? Well, we do that through OTMA. There's another address space called IMS Connect, which talks TCP/IP, and it sends in transactions through what's called the Open Transaction Manager Access Code, or OTMA. And then we also have a lock manager in IMS to manage locking for your databases, and that's called PI, or Program Isolation. So this is a high-level look at some of the functions that the IMS control region provides. And so when operations starts up IMS, this is the first address space that comes up, and it's called the IMS control region. It does some initialization, and then, onto the next page, the IMS control region will fire up another address space called DBRC. And DBRC stands for Database Recovery and Control. And that's what this address space basically does. It'll assist you in doing database recovery, and it'll also do some control functions that I'll talk about in just a minute. One of the key things that DBRC does is it does what's known as log control, which is it keeps track of the inventory of all your logs. As I mentioned earlier, we log pretty much everything that goes on in IMS. So that log data set is growing. And so how do we manage that data set? How do we know what's in that data set? Log records that were generated from the start of one time to the end of another time. How do we keep track of all that? And that's all done by DBRC, and that function is called log control. And DBRC records all the information that's related to database recovery and that's related to logging. That's all recorded in a data set called the recon. And you might be thinking, gosh, that sounds nuclear. But the word recon comes from two words. The RE comes from recovery, and the con comes from control, recovery control. And so all recovery and control related information that DBRC needs to remember is recorded in a data set called the recon. Now, DBRC is a very important part of IMS. You cannot, do any kind of recovery. You can't really keep track of your logs if you don't have DBRC. And so we're going to spend a little more time talking about DBRC in a little more detail. So first, let's talk about the logging function and how it's done in IMS and what DBRC keeps track of in terms of log inventory. So here we are on to the next page. We're going to talk about the logging facility in IMS. Very, very important, very crucial. If you go out and purchase any software and they promise you that they have data integrity and they promise you that they have recoverability, what's underneath all that is a very extensive logging system. And so it is with IMS. We have a very extensive logging system. So let's talk about logging. So who does logging? It's the IMS control region that does logging. And any event that happens in IMS, so for example, transaction comes in, transaction completes, program stops, a database is updated. All of these are events, things that happen in IMS. And when things happen in IMS, when events occur in IMS, the IMS control region will generate log records, and it'll write out these log records to what's known as log buffers, and it'll accumulate these log records in these buffers. Once the buffer fills up, it'll write the filled up log buffer to a set of log data sets known as OLS, online log data sets. And you can have a minimum of 3 to a maximum of 100 online log data sets, or OLS, and these are DASD data sets. And so what IMS starts to do is it starts to do logging on the first data set called OLS1. And it continues writing log records as events occur, as the log buffers fills up. They're all written up to the first OLS data set. When that OLS data set fills up, IMS will then switch to the next OLS data set, in this case OLS2, and it'll start writing log records to OLS2. And when OLS2 fills up, it'll switch to OLS3 and start writing to OLS3. As each OLS data set fills up, you can have the information on the OLS data set archived. And so there's a log archive utility. As each OLS data set fills up, the archive utility simply takes the information on the OLS data set and archives it to what's known as the system log data sets, or SLDSs. So archive, by the way, is just a fancy term for copy. That's all it is. So we take the information on the OLS data set, and then we copy it out to a set of data sets known as SLDSs. The SLDSs can be on DASD or they can be on tape. Typically, people will store them on tape because, as we'll see in a minute, you can generate lots and lots of SLDS data sets throughout the day. You also have the option of telling the log archive utility to take the information that's being copied from the OLS to the SLDS and to extract out database-related information only and put them on a separate data set called the recovery log data set, or the RLDSs. And you'd want to do that if the database takes a hit and you need to recover the database. It's faster to recover the database using the RLDSs as opposed to the SLDSs. Because remember, the SLDS has all the log records, whereas the RLDSs only have database change-related log information. And so that's what goes on all day long. As OLS1 fills up, we switch to OLS2. In the meantime, OLS1 is being archived to SLDS1, for example. When OLS2 fills up, we switch to OLS3. And we keep doing that until we get to the last OLS data set. And once that last OLS data set fills up, then we wrap around and reuse the first OLS data set. And we can do that because the information on the OLS data set has already been archived to an SLDS. So we don't lose that information. And so this goes on all day long. We use the OLS data sets in a wraparound fashion, and as each one fills up, we switch to the next OLS data sets, and we take that filled up information and we archive it out to the SLDS and or the recovery log data set. And so you can just imagine a very active IMS system. You know, maybe a very busy bank that's processing transactions, withdrawals, and deposits all day long. You know, we could have a lot of activity on that IMS system. And so you can generate a humongous amount of log information. But we can manage that because, if you think about this, the log is sort of ongoing because the OLS data sets are used in a wraparound fashion. Sometimes there are cases where, even though the log buffers have not filled up, but for integrity purposes, we need to take the log records that are in those buffers, and we need to write them out to the DASD device because we don't want to lose them. And so we don't want to fill out partially filled log buffers to the OLS data set. So what we will do is we'll write them out to the WADS data set. The WADS data set is known as the write-ahead data set. And again, it's a temporary place where we will write out partially filled log buffers for integrity reasons. And once the log buffer fills up, then we'll write it out to the OLS data set. And what's on the WADS data set, we don't need that information because now we've recorded that stuff on the OLS data set. So you can see that at any given point in time, there's one OLS data set that's in use. And then the other OLS data sets are either available or they are filled up and being archived or need to be archived, right? So who keeps track of all this? And then what are the SLDSs that are generated? What are their data set names? When they house log records, what's the time frame for which they house the log records? Who keeps track of all this inventory? That's done by DBRC. So DBRC keeps track of IMS's log inventory, and it does that in the recon data set. And DBRC has, and we recommend that people have, basically work with 3 recon data sets. There are 2 that act as a pair. In case one goes wrong, we always have the second pair. And then we have a third that's sort of a backup. In case one recon goes bad, we can always switch it and use the backup. So you always have a pair of recon data sets. So this keeping track of your O's, your SLDSs, your RLDSs, this keeping track of the log inventory data set, that's done by DBRC, and it's recorded in the recon data set. Very, very important, very vital function of IMS. By the way, if you're a DB2 user, DB2 has a similar, pretty much the same, I would say, logging environment, and they record their inventory of log data sets in a data set called the bootstrap data set, BSDS. So the equivalent in IMS would be the recon. That's where we keep our log inventory, if you will. Okay? So come on over to the next page. So that's one function that DBRC does. It's something called log control, where in the recon we record information about the O's, the SLDSs, and the RLDSs. And DBRC, if a log data set needs to be recovered or the archive utility needs to be manually kicked off, DBRC will generate the JCL. You can enter a command to DBRC, and it'll generate the JCL to kick off the utilities that will do the log recovery or the log archiving, if you will. Right? Come on over to the next page. Let's talk about DBRC in a little bit more detail. So we already mentioned that DBRC does something called log control, where it keeps track of the log inventory of IMS. It keeps track of the statuses of the O's. You know, you'll see statuses like archive needed, or an O's is available, or an archive is in progress, and so on. There's another thing that DBRC does, and it's called share control. And share control includes what used to be called in prior versions of IMS recovery control. And with share control and it includes recovery control, DBRC can assist in database integrity and recovery. What you do is you register your databases with DBRC. You tell DBRC, out of my, 400 databases, here's my 350 databases that are very important to me, and I need you, DBRC, to assist me in recovering these databases if something goes wrong. So DBRC will record for those databases that are registered with DBRC. DBRC will record when an image copy was taken. DBRC will record when change accums were done, when database recoveries were done. And again, DBRC keeps track of all of this information where? In the recon data set. So that's part of recovery control, where it helps you in recovering a database if the database needs to be recovered. The other thing that DBRC does is it assists in what's known as share control. And share control allows you to do database sharing across multiple IMSs. So if you've got multiple IMSs, you've got IMS 1 here and IMS 2 here and IMS 3 over there, they can all access the same set of databases, right? And so DBRC will get involved in share control. And there are various levels of database sharing. There's database level sharing, there's intra-block level data sharing, there's inter-processor block level sharing, and we'll talk about all this stuff in another video when we talk about database sharing. Now, by the way, there's no DBRC parameter or IMS parameter that determines whether you're using DBRC in log control mode or share control mode. Share control is ineffective for individual databases after they're registered with DBRC. So the advantages of registering a database with DBRC, well, DBRC will keep track of all recovery-related information for that database. And if the database takes a hit and you need to recover that database, DBRC will know which logs to use. DBRC will know which image copies it needs of those databases, and it'll generate the JCL, and all you do is just simply execute the JCL, and the database will be recovered for you. Okay? And of course, after a database is registered, you can also do share control, which is sharing a database amongst multiple IMS systems. So come on over to the next page. We talked about DBRC. We talked about log control and share control. Those are the functions that DBRC provides. So let's go back. IMS Control Region, if you remember, was the first address space that starts up. IMS Control Region fires up the DBRC address space. There's another address space that there's another address space the IMS Control Region fires up, and that's called the DLISAS address space. DLISAS stands for DLI Separate Address Space. And we have a separate address space, a separate set of modules, and their job in life is simply to process DLI calls. If you remember from video 1, we talked about how the way you can access IMS databases, one of the ways that you access IMS databases is by issuing what's called DLI calls. DLI stands for Data Language Interface. And so whenever application programs execute in dependent regions, whenever application programs issue DLI calls, those DLI calls are sent to the DLISAS address space. The DLISAS address space then goes out to the databases, gets the data, and then returns it back to the application program. By the way, the DLISAS region only processes DLI calls to access what's known as full function databases and HAL-DB databases. It does not provide access to what's known as FastPath databases. The FastPath databases are accessed through the IMS Control Region. Now at this point you're probably saying, what's a full function database? What's HAL-DB? What's a FastPath database? And yes, we haven't talked about that yet, but we'll talk about that in later YouTube videos that we'll put together. But for now, just know that whenever an application program issues DLI calls to IMS full function databases or HAL-DB databases, those DLI calls are processed by DLISAS. It goes out to the database, fetches the data, and then returns it back to the application program. Okay? So these are the three system address spaces. So when operations starts up IMS in the morning, the first address space that comes up is IMS Control. The IMS Control Region will then fire up the DBRC address space, and the IMS Control Region will also fire up the DLISAS address spaces. So there are no application programs that execute in these three address spaces. These are what I refer to as system address spaces. And after these three address spaces are started, IMS will put out this message, DFS 810 ABLE, IMS ready. It says, okay, these three address spaces have been started up. Now what do you want to do? And after this message, you can then enter a command into IMS and tell IMS what sort of a start are you doing. You're starting up IMS, but what sort of a start is it? And there are three different types of starts. There's what's called a cold start, there's a warm start, and then there's an emergency restart. A cold start says, we're starting out IMS as if it was starting out for the very first time. So if you had shut down IMS yesterday, we have no knowledge of what happened yesterday. We're starting out fresh. So if you had any transactions left over from yesterday and you do a cold start, guess what? You've lost all those transactions. So a cold start is a way of starting out clean, right? Sometimes I wish we could do that in life every day, and when you wake up in the morning, you start out fresh. But anyway, the other thing is you can do what's called a warm start. A warm start is where, you shut down IMS yesterday, and then when you do a warm start, you're saying, well, continue processing from where we left off. So if you had, 15 transactions left off from yesterday, well, they're not lost because you're doing a warm start, and IMS will know that those transactions are still there, and then IMS will go ahead and continue processing them. And then an emergency restart is done when IMS crashes. If something goes wrong and IMS, which by the way, hardly happens, but if IMS were to crash, an emergency restart says, figure out what IMS was doing just before it crashed, and then restart IMS just before it crashed. Right? So what you would typically do when IMS crashes is determine, why did IMS crash? Go fix that problem, and then do a restart of IMS and specify emergency restart, and IMS will start off just from before it crashed and then continue processing. After you tell it what sort of a start you're doing, then you'll get this DFS 994I message that says, cold start complete or emergency restart complete. And now the IMS system address spaces are up, and now you're ready to start what's called the dependent regions. You still can't use IMS yet. You have to fire up dependent regions because that's where application programs will execute, and those application programs will process transactions and access databases and so on and so forth. So these are, at a minimum, these are three address spaces any IMS shop will have when you first start up IMS. And once you get the DFS 994 message, then operations will start up some of those dependent regions that we had mentioned earlier. And so what we're going to cover in our next video is the IMS dependent regions. And here's a picture again of our IMS online architecture overview. And we talked about control region, DBRC, and DLISAS. And in our next video, we'll talk about the dependent regions. We'll talk about the different types of dependent regions there are, NPRs, BMPs, IFPs, JMPs, JBPs, and why you need one over the other. Okay, my name is Deepak Kohli. I'm with the IMS Product Management Team in Silicon Valley Lab at IBM. If you have any questions, please post your questions on the IBM forum on LinkedIn, or send me an email. I think the email was on the title page in this YouTube video, and I'll see you in part 3. Thank you.